Hello dear students of plus 2 medical and non-medical respected teachers. Today I am going to discuss a very important topic known as electric field due to a continuous charge distribution. So we will find expression for electric field due to a continuous charge distribution. So continuous charge distribution is of three types. Number one, line charge distribution. So we have to find electric field due to a line charge distribution. Suppose AB be a charged wire, say positively charged, and let P be any point where electric field due to this charged wire is to be determined. Let Q naught be the test charge at point P, which is at location R vector from the origin. Let this charged wire is made up of a large number of small elements. Let one such element of length dl having charge dq say at location r vector dash from the origin. So let lambda r dash is equal to linear charge density, that is charge per unit length of the line charge. Then small amount of charge upon the small current element of length dl is given by dq is equal to lambda r dash dl. Then by vector form of Coulomb's law, electric force experienced by this test charge due to the small current element is given by df is equal to 1 upon 4 pi epsilon naught q naught dq r vector minus r dash vector divided by r vector minus r dash vector mod q. So this gives electrostatic force due to small current element at P, that is at test charge q naught. Then total electrostatic force on q naught is given by q naught upon 4 pi epsilon naught line integral a to b, because it is continuous charge distribution, so we have to integrate lambda r dash dl r minus r dash upon r minus r dash mod q. Now if E is the electric field at P, then electric field is defined as electrostatic force per unit test charge, that is total electrostatic force at P which has unit positive test charge due to line charge distribution is called its electric field. So E electric field is equal to F vector upon Q naught is equal to 1 upon 4 pi epsilon naught line integral A to B lambda r dash dl r minus r dash upon r minus r dash mod q. So which is required expression for electric field due to a continuous line charge distribution. Clear? Next, electric field due to a surface charge distribution. We'll repeat all the steps but with a little difference. So suppose continuous surface charge having surface charge density sigma r dash, that is charge per unit area. Let P be any point where electric field due to this surface charge distribution is to be determined. Let Q naught be the test charge at P at location r vector from origin. Let a small element of area ds having charge dq at location r dash vector. Then similar steps by vector law, Coulomb's law vector form, Coulomb's law in vector form. So df vector is equal to 1 upon 4 pi epsilon naught q naught dq r minus r dash upon r minus r dash mod q. Same. Or total force due to the whole surface charge distribution S is given by F vector is equal to q upon 4 pi epsilon naught surface integral over the entire surface S sigma r dash ds into r minus r dash upon r vector minus r dash vector mod q. This is vector form of Coulomb's law. Therefore, electric field due to this whole surface charge distribution at P is given by E is equal to F vector upon Q naught is equal to 1 upon 4 pi epsilon naught surface integral sigma r dash ds r minus r dash upon r minus r dash mod q, which is required expression for electric field due to continuous surface charge distribution at a given point. Third, electric field due to a volume charge distribution. Now, instead of surface charge, suppose we have a volume of any shape, charge distribution having volume V. Again, let P be the point where electric field due to this volume charge distribution is to be determined. Let Q naught be a test charge placed at P. Let R vector is equal to location of point P, and let a small volume element of volume dV having charge dQ at location R dash vector. Let rho R dash is equal to volume charge density, that is charge per unit volume. Then small amount of charge upon volume dV is given by dQ is equal to rho R dash, that is volume charge density into volume of the element. Therefore, by Coulomb's law in vector form, electrostatic force due to this small volume element at P is given by dF vector is equal to 1 upon 4 pi epsilon naught Q naught dQ R vector minus R dash vector divided by R vector minus R dash vector mod Q. Therefore, total electrostatic force due to whole volume charge distribution at P is equal to Q naught upon 4 pi epsilon naught volume integral over the entire volume charge distribution. So, rho R dash dV R minus R dash upon R minus R dash mod Q. And at the end, electric field due to the whole volume charge distribution at P is given by electrostatic force per unit test charge. So 1 upon 4 pi epsilon naught volume integral rho R dash dV R minus R dash upon R minus R dash mod Q, which is required expression for electric field due to continuous volume charge distribution. So देखने में थोड़ा वेक्टर फॉर्म डिफिकल्ट लगता है, बट स्टेप्स सारे सिमिलर ने और ये ध्यान ना एक बार इनू स्टडी कर लोगे, वॉच कर लोगे प्रॉपर वीडियो नु, यू विल अंडरस्टैंड ईच एंड एवरीथिंग. थैंक यू, ऑल द बेस्ट, बी हैप्पी एंड गुड लक.